Welcome to part 2 of my two-part series on integrating Playwright automated tests into a CI/CD pipeline using AWS CodePipeline. We're going to cover quite a lot of ground in this video, so I thought it would be useful to start with a roadmap of what we're actually going to go over. There are actually 10 sections in this video that we'll quickly go through. The first is a quick recap of where we finished in part 1. The second is a description of the problem we're trying to solve and why AWS CodePipeline is the answer to that. An overview of the architecture for our solution is next, and then followed by deploying the actual application under test into AWS. Then we're on to Playwright and how we originally built the test locally and how it is now going to operate in a cloud-hosted application and what changes are required, if any, to that Playwright test. We then need to look at AWS CodeBuild and why we need to use it, and then we'll do the actual build through AWS CodePipeline. Then we need to look at triggering and what triggers the pipeline and how those triggers are implemented. And then finally, we'll look at catching problems when a developer actually makes a change to the application that is breaking those tests and what happens then. And finally, we'll summarize what we've gone through. In part 1 then, we had looked at a very simple real-world function on the Gov.uk website that performed a simple postcode lookup function. We then created a simple mock of that application running locally and a behavior-driven test that replicated a basic user journey. From there, we created an automated version in Playwright before finally moving both the automated test and the mock application into a single GitHub repository. Before we build anything further, let's first define the problem we're trying to solve. I've often worked at companies where there are extensive automation test suites. However, to run them, you first have to chase the developers for the latest build and then spin that build up locally. Meanwhile, the developers have moved on. They're working on the next user stories and committing new changes to the application. By the time the testers receive the build and execute the automation suite, the developers may already be several commits further ahead. Now, that's not a weakness of the test automation, that's a weakness of the process as is surrounding it. Modern software teams are moving away from this model towards automated testing that runs consistently and automatically as part of the software delivery process. Now, that's when continuous integration and continuous delivery pipelines come in. They monitor for the code changes, they trigger the new builds, execute the automated tests, and decision is made whether a deployment should continue or be stopped. In this video, we're going to build exactly that using AWS CodePipeline, transforming the Playwright test we have from something that runs on a local laptop into an automated quality gate that's fully integrated into the software delivery pipeline. Now, everything starts with getting our application into the cloud, so that's where we'll begin. So now we need to start looking at the AWS console. So far, all I've done is create an AWS account and then create an admin user. Then I've logged out of root and back in as the new admin account. The first service we're going to use is Elastic Beanstalk. You can think of Elastic Beanstalk as a managed application hosting service. We simply provide our application and AWS takes care of the underlying infrastructure for us. The first step is to create a new application, and as part of that process I need to tell AWS which platform my application uses. In this case, I built the application in Python, so that's the platform I need to select. Now we're going to try and automate deployments, so the next step might seem a little confusing. To create the Elastic Beanstalk environment, AWS requires me to upload the application manually from my local machine. So why do I need to do this? Well, the reason is that Elastic Beanstalk is an application deployment service. It's not an infrastructure provisioning service. So this means that when it creates an environment, it expects there to be an application ready to deploy. It isn't designed to create an empty environment that's simply waiting for CodePipeline to connect to it. So this manual step is a necessary one-time bootstrap step. The point is that later in the video, once we've connected GitHub to AWS CodePipeline, this manual deployment step will disappear completely. From that point on, every new deployment will be triggered automatically whenever code is pushed to GitHub. For now, though, we need this initial deployment to create our cloud environment. So I'm going to upload a zip file from my local machine. This zip This zip file is simply a compressed version of my postcode application from my local machine. The next section asks us to configure service access. Now, Elastic Beanstalk will need permission to create and manage the AWS resources on our behalf, which is why we need to configure a service role and EC2 instance profile. For this demo, I've simply accepted all the default options and allowed AWS to create the recommended roles for me. The remaining configuration steps are all optional, and for this simple demonstration, we don't actually need to change anything. One of the things that's really good about AWS is that it's often possible to get something up and running very quickly by accepting all the recommended defaults. You can always come back later if you need to fine-tune the configuration as your application grows or your requirements become more complex. So apart from providing my application code, I've actually had to change very little. Everything else has been left as the default settings. And now if I click create, with a bit of luck, AWS should provision the infrastructure and launch the new Elastic Beanstalk environment. Now that AWS has finished provisioning the environment, if I click on the application URL, you can see that with just a few clicks, we've taken our application from a local development machine and deployed it into our new cloud environment. So the next step is to return to the Playwright script we created in part 1 of the series. You might remember when we built the test, I deliberately coded it to accept an environment variable rather than hard coding the application's URL. Hopefully the reason for that is now becoming clear. Instead of pointing the test at my local machine, I can simply update the environment variable with the URL of our new Elastic Beanstalk environment and run exactly the same Playwright test against the cloud-hosted application. No changes to the test itself are now required. The target environment is all that has changed. So our application is now running in the cloud, and we can see that our existing Playwright test can successfully execute against it. The problem is that I'm still triggering that test manually from the command line on my local machine. What we're aiming for is for the test to run automatically whenever new code is committed into GitHub without any manual intervention. So that's where we need to look at AWS CodeBuild. CodeBuild provides a temporary build environment in the cloud. It checks out the source code, installs the required dependencies, and then executes the Playwright test suite. In other words, it replaces the manual command line with an automated build and test process. One important point to understand is that it's CodeBuild that's actually executing the Playwright test. CodePipeline is the workflow orchestration that we need to configure later, but first we need to configure CodeBuild, and then we'll bring everything together by connecting it into AWS CodePipeline. So I need to select CodeBuild and then select Create Project. The project needs a suitable name, so I'll start by adding that. Next, I need to tell CodeBuild where my source code lives, so I'll select GitHub as the source provider. I've already linked my AWS account to GitHub, but if you're following along for the first time, you'll be prompted to authenticate and authorize AWS to access to your repositories. Once that's done, I can simply select my repository from the drop-down list. For the build environment, I'm going to leave the image as managed and set the running mode to container. Then choose Ubuntu as the operating system, select the standard runtime, and use the latest available image. At the time of recording this video, you can see that that's currently standard version 8. This gives CodeBuild a temporary Linux environment where it can install our node dependencies, install the Playwright browsers, and execute the test suite. The most important part of the project configuration, though, is the build spec YAML file, so we need to take a closer look at that one. We've already discussed the environment variable. Now that our application is running in Elastic Beanstalk, we can simply set the base URL variable to point to that cloud application, and Playwright tests will now automatically use that address. Remember that every CodeBuild execution, though, will start with a completely clean environment. Nothing is pre-installed, so the first phase is all about preparing the build environment. During the install phase, we install the Node.js dependencies and then install the Playwright browsers and their required system packages. Once that's complete, the build phase is actually very simple. We're running exactly the same Playwright command that we executed manually from the command line earlier. The only difference is that CodeBuild is now doing it automatically in the cloud. Finally, the artifacts section tells CodeBuild which output files should be collected after the build is finished. This will include the Playwright HTML report and test results, making it much easier for us to investigate any failures. Once you've created the build spec YAML file, save it to the root of the local repository and then push it to GitHub so it's ready for CodeBuild. By default, CodeBuild expects to find it in the root of the repository, so no additional configuration is now required. So as long as you've pushed the build spec file to the specified repo, then we can select Build the project. Jumping ahead now, if that completes okay, we're now in a position to do the test. So let's do Start Build. So now we can see we have a successful build. So what has CodeBuild actually done? Well, it's cloned the repository from GitHub, it's created a temporary Linux build environment, then installed the dependencies, and then executed our Playwright test against the cloud hosted application that we've specified. And only then has it reported the build as successful. At the moment, we're still triggering the CodeBuild test manually, and it's running against the existing Elastic Beanstalk environment that we provisioned earlier in the video. The missing piece now is orchestration. We need something that can monitor our GitHub repository, coordinate our deployment, trigger the Playwright tests, and then make a pass-fail decision. And that is exactly what AWS CodePipeline is designed to do. Back to the AWS console then. What I'm going to do to start is create a pipeline to deploy the application to Elastic Beanstalk. So select CodePipeline and then Create Pipeline. And we want to build a custom pipeline. Give the pipeline a suitable name and leave the option to create a new service role. Click Next there. For source provider, we want GitHub with the app. Select the offered connection already established, and that then populates the available repositories. And then we need to select the branch as main. On event type, let's choose push so we can demo a push starting the pipeline, and we're looking for a push to main, so let's set the filter type to branch and then simply enter main. We can click next there. The build section we can skip as this app does not need compiling and the build is being handled by Elastic Beanstalk. Test stage I'm also going to skip as we need to get the deployment working first. And then in the deploy section now, I'm going to choose AWS Elastic Beanstalk. The region is already correct. Input artifacts needs to be set to source, and as I want GitHub repository as the source artifact. I've built the application a few times, but postcode lookups was the latest, so I'll select that as my application name. That then should populate the environment name options. I can then click next, and then I should be onto the review section. So if I got everything correct, at this point I should be able to click Create Pipeline. So all the pipeline is doing so far is pulling the source code from GitHub and then trying to deploy into Elastic Beanstalk. And as you can see, the pipeline is created, but the deploy has actually failed. So if we now click into that failed step, that is telling me that the provided role does not have the Elastic Beanstalk create application version permission. Hopefully that's an easy fix of just assigning that permission to the role. So if I now open the console in a new tab and go into access management, we can see a list of roles created so far, and post check pipeline was the last one I did. So if I click add permission and attach policy there, I now need to search for AWS Elastic Beanstalk available roles and policies, and I'm going to go for administrator access and add that permission. So if I now go back to the failed pipeline and click rerun, hopefully we will now get a success. Now I'm getting a successful deployment, so the individual components are now starting to come together. The final step is to connect what we've done so far in the correct order inside CodePipeline. So next I'm going to modify the pipeline and add the CodeBuild project after the Elastic Beanstalk deployment stage. So I now need to edit and scroll down to the deploy, and then you'll see here that I can add a stage. So I need to give the new stage a name, so let's call it post deploy test. In my new stage now, I need to add an action group. The action needs to have a suitable name, and then here I can tell it my provider, and that's going to be AWS CodeBuild. And the incoming artifact will be source, and you can see that the CodeBuild project is now populated. And as our CodeBuild was already tested, that should be all we need. So let's click done here and then save, and then we can see that the pipeline now has a new stage. So in theory, all I need to do now is release the change to run the pipeline again. Everything is now flowing through the pipeline automatically. CodePipeline detects the latest version of the application in our GitHub repository and passes it to Elastic Beanstalk for deployment. Once the deployment completes successfully, then CodeBuild is executing the Playwright test suite against the newly deployed application. So we're almost finished. The final piece of the puzzle is to look at what happens when a developer commits a code change and how that automatically triggers the entire pipeline from start to finish. Now, if you remember when we created the pipeline, we populated this webhook section, and we said that we wanted to start the pipeline on a push event. So let's briefly swap to the command line once we also have our pipeline on screen in the background. So I've made a very small change to the index HTML file in the application. So that file should now show in Git as modified. So if I stage that change and push it to the repository, in theory, we should see that the pipeline triggers automatically in the background. There's a slight delay while GitHub registers the push, but as you can see, the pipeline is now triggered automatically. The final demonstration is to show how the Playwright test can act as a quality gate. I'll introduce a breaking change, commit it to the repo, and then we should see the pipeline detect the regression and fail the testing stage. So let's imagine the developer is handling a postcode update and mistakenly associates the test postcode with Milton Keynes Council. So they modify the application code and they remove Buckinghamshire, and instead we put in Milton Keynes. So if we now save that in Visual Studio Code and go back to the command line, then that change to the application should be registered in Git. So I can now stage, commit, and push that change. And if we now look at our pipeline running in the background, it should again pick up the trigger action, but this time we should also see the postcode deploy stage fail.
To summarize then, we looked at a real world government website, looking at postcodes. Hopefully looking at a real world scenario is quite useful. We considered how we might set up a test against that site, and from there how we might automate that with Playwright. We then considered in a real world development team how the developers are often quite a lot further ahead than the testers. So from there we discussed how we might look to resolve that issue or help resolve that issue with CI/CD. And then we brought in the AWS resources. AWS, mostly because I'm most familiar with it. So hopefully going through CodePipeline, Elastic Beanstalk, CodeBuild, hopefully that whole scenario is quite useful to you. It's definitely useful to me because it helps consolidate my understanding. But if there's any other automation testing you'd like to go through, anything related to AI especially, then please add in the comments, because that's always really useful to me in terms of what next videos to produce. For me, particularly, I'm going to start looking now, going away from automation slightly and looking at using AI in job applications. I know there's a lot out there on that already in terms of ATS systems, the applicant tracking systems, but I work contracts, so for me, I'm kind of familiar with how the agents work, so I know that ATS is important. You often have to pass ATS to actually get to the agent themselves. But for me, it's the agents who are actually submitting the CV, the resume to the end client. And I know that these days agents are quite restricted on the number of CVs they can actually put in front of a client. So how we might leverage AI, not just to pass the ATS, but to get to the point where you get an interview, because ultimately getting interviews is what we're trying to do. So hopefully a video on that, and how AI can help with that, would be useful to you. So I'm going to do that next. If that appeals, then please subscribe. But again, anything on automation, also great to go through on comments and give me further ideas of how to improve the channel. Thanks very much.